Hey guys, it's Mrs. Rice. Today I'm going to talk to you about an introduction to proofs. So, here we go. So, the first thing we need to talk about is important vocab that we're going to see along the way. So, first is a proof. So, a proof is a logical argument in which each statement made is supported by a reason. A postulate is a statement that is true without proof. And a theorem is a conjecture or statement that you prove is true. So these words are important in this lesson, first and foremost, because what we're talking about is a proof. So it's important to know what a proof exactly is. And then postulates and theorems are used within the proof as justifications for certain statements that we make. Moving on. Okay, so the format that we're going to talk about is a two-column proof. So a two-column proof will look like a T-chart for you. And then on the left side of the T-chart, there should be statements. So you would label that column statements. And then on the right side of the T-chart, it would be reasons. And you would label that side reasons. So that's very important that you label everything. So in the two-column proof, like I said, the left side is statements. And statements are like, it could be something like angle A is congruent to angle B. It could be something like x plus 5 plus 3x minus 7 equals 90. Those are examples of statements. And then reasons, the examples for reasons could be something like segment addition postulate, which we've talked about, or angle addition postulate, or basically any postulate or theorem that we've discussed, as well as definitions, or properties, stuff like that. So that's what would go on the reason side. And what the reasons are is they're the explanation for why we made the statement or why we can say the statement. So what you'll see is when you do two-column proofs, everything should be numbered because every statement you have should have a corresponding reason so that you justify your steps along the way. Now you'll see that with statements, there should be this logical chain of statements so that you can connect the previous statement to the next statement. And at the end, it should be exactly what you're trying to prove. The first statement is usually going to be the given information. So whatever the problem provides to you initially, that's the first thing you would want to write down. So typically people put that information in the first step in the statement, and then the reason for that would be given. And then everything from there is based off of that information or the picture provided and what you know about the diagram that you're dealing with. And the last step will always, the last statement will always be what you're trying to prove. The reasons will always vary because it depends on how you're approaching the problem, but the last step, the statement will always be word for word what they tell you to prove. So I'm going to show you an example of one. Okay, so here we go. This is an example of a proof. So it says to us over here, it says given B is the midpoint of segment AC. They also tell us that AB is 8. They want us to prove that CB is also 8. Now this seems redundant. I bet you're sitting there going, oh my God, Mrs. Rice, this is so stupid. Yes, it's very redundant because you have to explain everything that you're dealing with. As if you were explaining it to someone who's never ever seen this before in their life. So the first thing I would do is if they don't provide you with a picture, I would draw everything that they're telling you. So B is the midpoint of AC. So here's my drawing. B is the midpoint of AC. So I mark what's congruent because I know what midpoints do. And I marked that AB was 8. Okay. So they tell us All right, here's my two-column proof. My statements are on the left, my reasons are on the right. Since we typically start proofs writing the given information down in the first step, I'm going to write B as the midpoint of AC and AB equals 8 over here. And on the right side, the reason that goes with it, I'm going to write given. So it looks like that. Okay, from here, I've already marked the diagram, but we need to mention in our proof that because B is the midpoint of segment AC, that means that AB and BC are congruent. So that is the next thing I would write in my statements. And the reason I'm going to say that is because we know that by definition, what a midpoint does is it divides a segment into two congruent segments. So since I've used the definition of a midpoint, that's exactly what the reason is going to be. So see, there we go. AB is congruent to CB. Definition of midpoint. Okay. Hopefully you're still with me and I haven't lost you yet. So from there, I'm going to say, okay, what else do I know then? If I have two congruent segments. So that's the first thing I have to ask. The second thing I have to ask myself is, how am I going to get to equality so that I can show that CB is also 8? And what you should answer is, oh, if your items are congruent, then you know that their measures are equal because congruent items have the same measure. So that's the next thing I'm going to do. I'm going to say that the length of AB is equal to the length of CB. And I'm using the definition of congruence to say that because, again, I know that if things are congruent, they have equal measures. So I'm going to write that next. There we go. So AB equals CB, definition of congruence. Now, you should say, oh, awesome. I can do my last step now. I can prove what I need to prove. Because if AB equals CB, and you know that AB equals 8, then all you have to do is use substitution to say that CB equals 8. So I remove, technically what I'm doing is I'm taking this AB equals 8, I'm removing the AB, and I'm substituting it with a CB because I know that they're equal. So that's the last thing I'm doing. I'm saying that CB equals 8, and that's because I'm using substitution. So I opened with what they provided me, which is the given. My last statement, like I said before, should be whatever you're trying to prove, and I used a logical flow of statements in order to get to my reason. I hope this was helpful, guys. We will do a whole bunch of proofs in class. And if you have any questions, make sure you ask me tomorrow in class. Have a great night, guys. Bye.